In class example 3.33, we're given three logarithmic terms to evaluate. We're going to try to do this without using our calculator. So in each one, we'll ask ourselves, what exponent would be written on the given base in order to generate the argument? In this case, part A, we would say what exponent is written on the base of 2 in order to generate an output of 1 over 32. Because we're given an expression, there isn't really a need to write this as an equation equal to x. You could just say, I know that the exponent that goes on 2 to make 32 is 5, and so to make 1 over 32 is negative 5. However, if that's not as obvious, sometimes it's easier for students to see the exponential form written first. So we've introduced this equals x, really is meaning equals the answer. We then rewrite this as 2 to the x equals 1 over 32, rewrite both sides with a base of 2, at which point we find that 2 to the x is 2 to the negative 5, so the x must be equivalent to negative 5. Note, when we talk about domain restrictions with logarithmic expressions, the argument cannot be negative or 0, and the base cannot be negative or 0. However, the answer, which represents an exponent, can be negative. In part B, we're asked what exponent would be written on 1/3 to generate an output of 9. Maybe start with the question, what exponent would be written on 3 to generate an output of 9? Since that answer is 2, and since 1/3 is the reciprocal of 3, the answer will end up being negative 2. Again, to make this a bit easier, we've written log base 1/3 of 9 equal to x, where x will represent our answer, and we've converted it to exponential form. So now we have 1/3 to the power of x equals 9. Both sides can be written in terms of a base of 3. So on the left side, we end up with 3 to the negative 1x, or 3 to the negative x, equals 3 squared, at which point we see that negative x is equal to 2, so x is equal to negative 2. Again, this answer does not represent an argument or base, so being negative is okay. In order to understand example C, note that when no base is written, there's an implied base of 10. This is called a common log. The next thing we need to understand is that decimal numbers such as 0.001 are more easily read as 1/1000th, because the third place after the decimal is the thousandths position. If we rewrite 1/1000ths as a fraction, it makes it easier to see that that is 1 over 10 to the 3, or is otherwise 10 to the negative 3. That way, we can say that 10 to the power of negative 3 would generate 1/1000th. Let's continue with examples D, E, F, and G. Please pause the video and try these on your own first. Example D has many rich opportunities for understanding. First, we'll continue to use the structure of introducing equals x in order to determine the value of the term, but I want to again point out that this is an expression and not actually something we're solving. What exponent is written on 3 to generate 9 times the square root of 27? I'll first note that in the unit of logarithmic and exponential functions, it's always the case that when we see a square root, or any root, we want to rewrite it using a rational exponent. So let's express the square root of 27 as 27 to the 1/2. Now we see that we have 3, 9, and 27 as bases. All of these can be rewritten as powers of 3. So 9 becomes 3 squared, and 27 becomes 3 cubed. We have two different power laws to apply here. The 3 to the power of 3 is raised to the power of 1/2. Here we will multiply the exponents together. 3 times 1/2 makes 3 over 2. Next, we have 3 squared times 3 to the 3/2. In this case, we are adding the exponents. 2 plus 3 over 2 requires us to write the 2 as 4 over 2 in order to have common denominators. 4/2 plus 3/2 gives us 7/2, which corresponds to the exponent of x. We can verify this on our calculator by evaluating the log, or by evaluating 3 to the 7/2 and confirming that's the same as 9 times the square root of 27. Part E is a conceptual question. What exponent will be written on the base of b to generate an output of 1? The answer to this question is always 0. Regardless of the base, if the output is 1, it's because the exponent is 0. Part F is another conceptual question. What exponent will be written on b to generate an output of b? Here, the answer must be 1. Question G gives us the answer in the question. What exponent will be written on 2 to give us an output of 2 to the power of 5? Well, the answer must be the 5. We see this when we convert to exponential form. This would be expressed as 2 to the 5 equals 2 to the x. So the x must be equivalent to 5. Generally speaking, anytime we're asked what exponent goes on a base to give that same base to a certain power, the power is in fact the answer.